Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics. We are starting a new chapter, chapter 3, motion in straight line. The topics discussed in this video are introduction, rectilinear motion, concept of point object or point mass, frame of reference, how to identify motion in 1, 2 and 3 dimensions. This video will present a few topics, the understanding of which is very important in understanding the concepts presented in this chapter. So watch the video completely without skipping, and if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. Please support me through your subscriptions. Also press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us see the topics. We are starting a new chapter, motion in a straight line, coming under the branch of mechanics, kinematics. What is mechanics? Mechanics is a branch of physics which deals with motion of material objects. Mechanics is really divided into three branches. Number one, statics. It deals with bodies at rest or objects at rest. Another branch is kinematics, deals with motion. But under this branch, the cause of motion, that is, unbalanced force is the cause of motion. That is not considered. When the forces acting on an object is balanced on all sides, then the body will be at rest. Or in other words, the total or net force acting on an object at rest is equal to 0. But in the case of motion, where the net force acting on the object is not equal to 0, the forces acting on it is not balanced. But under kinematics, the cause of motion is not considered at all. Now lastly, the third branch of mechanics is dynamics. It also deals with motion. But here it considers the cause of motion, that is the force. Time factor is not important under statics. For these two cases, time factor plays a role. Now let us see the definition for motion. It is the change in position with reference to time. When we look around us, we see different types of objects, that is living, which we call animate, like birds, ants, flies, worms, small animals and big animals, human beings, etc., etc. And inanimate or non-living things like waters of the river, ships on the ocean, airplanes, and all types of vehicles, etc., which are moving around in various directions. They change their position with a reference to time. That is, at one point of time, it is at one location. At another point of time, its location is different. So we say those objects are in motion. Those objects around us which are not changing their position with reference to time, we say are at rest. I will just note down the point, that is how we differentiate rest and motion. Rest and motion are relative. I will explain that with the help of an example. A person sitting in a moving car is at rest in relation to the car, but he is experiencing motion in relation to the external objects. So we have understood what is motion. Now let us see types of motion. If an object is moving in a straight line, it is called rectilinear motion, otherwise called translatory motion. Another type of motion is circular or rotatory motion. The third type is oscillatory or vibratory motion. I will not discuss types of motion in detail in this video. I will do a separate video for that. For the present, we are concerned only with rectilinear motion that we will discuss in detail. Rectilinear motion means motion in straight line. Let us see one example. A car is moving along the road in straight line. The road is perfectly straight line. It is not curved. Such motion is called rectilinear motion. We are discussing rectilinear motion under kinematics. That is, we will not consider the reason for motion. We will only discuss certain other features related to rectilinear motion. But before we pass on to the details of that, we have to familiarize with a few terms. The first one is the concept of point mass. In order to understand this, we will again consider certain examples. The Earth revolves around the Sun in its orbit. The distance traveled by the Earth in its orbit is much, much greater than the diameter or the size of the Earth. Therefore, Earth is considered as a point mass or point object in this case. It will be very hard to consider the Earth as a point mass because we know the Earth is a very huge planet and its mass is very great. But when we consider point mass, we take into account the distance traveled in relation to its size. So, if the distance traveled is very great when compared to the size of the object, then that object is called point mass. Let us take another example. A teacup rests on this table, and if it slips down, the distance traveled by it is much smaller than its size. So, the cup cannot be considered as a point mass in this case. Distance traveled by the cup is only this much, short distance. The size is much bigger. Now, let me note it down. Cup is not a point mass in this case. Yet another example, a train moving on rails. The distance traveled by the train is much greater than the size of the train. So the train can be considered a point mass. Let us take this example. If this car is traveling only a very short distance, then the car cannot be considered a point mass. But if the car is moving several kilometers, then the size of the car becomes less and the distance traveled by the car becomes more. In that case, car is a point mass. So, it is not the real size or real mass of the object that is considered while determining whether an object is a point mass. It is the distance traveled by the object that is taken into consideration. If the distance traveled is great and the size is less, then it is a point object. On the other hand, if the distance traveled is less and the size is more, then it is not a point mass. In the question paper, a few live situations are given and you are asked to select those situations where the object given is considered as a point mass and in which case it is not considered a point mass. You may also be asked to give reasons. So I hope it is clear. Now we will see the next term, frame of reference. Let us see what this frame of reference is. Let us suppose a person is standing at a location. He is observing an object moving along this direction, or he is observing a bird flying. In order to refer to the position of the observer and the change in position, that is movement or motion of the objects, it is best to consider, it is the convention rather, to consider the rectangular coordinates. This line can be taken as the x-axis. This is the y-axis and this is the z-axis. You know, these three coordinates are mutually perpendicular. This constitutes the rectangular coordinate. I will mark x, y and z. O is the origin and it is the place where all the three coordinates intersect or cross. The person stands at O. This portion of the x-axis is positive x. This is negative x-axis. Similarly, this is marked negative z-axis and this is negative y-axis. Motion is change in position with reference to time. So he has also to note the time. So he stands with a clock or a watch. The coordinate system with the watch or the clock is what is called frame of reference. The frame of reference can be inertial frame of reference or non-inertial frame of reference. Let us take one example. Let us consider we want to know or study the motion of a bus. Then we have to travel in the bus and then study the change in position with reference to time. If the bus is moving with uniform velocity, then the frame of reference that is considered there is inertial frame of reference. On the other hand, if the bus moves with non-uniform velocity, then the frame of reference is known as non-inertial frame of reference. Inertial frame of reference obeys Newton's first law of motion. Non-inertial frame of reference does not obey Newton's first law of motion. That is one difference. Rectilinear motion or motion in a straight line is also called motion in one dimension. So we will first see what is meant by motion in one dimension, two dimension and three dimension. In the rectangular coordinate system, there are three coordinates. If only one coordinate is used to describe the motion, then it is motion in one dimension, as in the case of rectilinear motion. If two coordinates are used to describe the motion, then it becomes motion in two dimension. If all the three coordinates are used to describe the motion, then it is motion in three dimension. In this chapter, we are discussing motion in one dimension. Motion in straight line is motion in one dimension. The motion of the bus, which we saw here, is motion in one dimension. Okay? We will see the examples for 2 and 3 dimensions when we come to that chapter. Okay? I hope this video was of great use to you. If you think the video was useful, do like the video. Share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe my channel now and support me. And also press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with the next topic. Till then, bye. Take care.